The first two questions here, although they are numbered 3 and 4, talks about triangles, and specifically the property that we learned that for any 3 sides to form a triangle, the 2 smaller sides, the sum of the 2 smaller sides, has to be greater than the largest side. Okay? So for example, if I have if I have a triangle, 5, 7, and 12. Okay? So the 2 smaller sides are always your A and your B. And that sum has to be greater than the longest side, which is always represented by C. Now if you notice, 5 plus 7 is 12. So 12 is not greater than 12, so those 3 lengths cannot form a triangle. Okay, so that is the property that we are working with, okay? Now, while I'm not fond of the square roots, if we notice that of the 3, they're all squared. And anytime you square something, anytime you square a square root, you get the number inside the radical. So for example, if I have the square root of 5 squared, that's the same as the square root of 5 times the square root of 5, which is equal to the square root of 25, because 5 times 5 is 25, and the square root of 25 is the whole number 5. So that's what I mean when you square something inside the radical, you just get that number, that whole number inside. So if you look at question 1, this is saying, okay, 13 is greater than 5 plus 12. Well, that's not correct, because 5 plus 12 is 17, and 3 is not greater than 17, so that doesn't work. And 13 does not equal 5 plus 12. So it has to be C. 13 is less than 5 plus 12, which equals 17. So yes, 13 is less than 17. So that is our correct answer. D, you can't add these. Mathematically, to add square roots, you have to have the same number inside. So for example, if I had 4 square root 2 plus 5 square root 2, that would be 9 square root 2. Okay, when you're adding square roots, they act like variables. So mathematically, you can't do D. That's one of those choices that just doesn't make any sense and is not possible. So my answer is C, because this statement is true. 13 is less than 5 plus 12. Okay. So we're going to do the same thing for number 4. Determine whether the measures 9, 40, and 41 can be the measures of the sides of a triangle. If so, classify the triangle as acute, obtuse, or right. Okay, so in this case, thankfully we have whole numbers. And you would obviously be allowed to have a calculator on your exam. So 41 squared is 1681. 40 squared is 1600. and 9 squared is 81. Okay, well, this is correct. 1681 is less than 1600 plus 81. But if you notice, it's more than that. Actually, it's not less than, because 1600 plus 81, oops, sorry, actually equals 1681. So it's not greater than, it's actually equal to. So it's not A, it happens to be B. And if the numbers are equal, then they are a right triangle. And that's based off of A squared plus B squared equals C squared. So I apologize for not doing the addition and assuming A was the correct answer. This is why you always double check and read all of your answer choices, because then you're able to catch whether or not you made a mistake, which I just did.